Hello and welcome to my YouTube channel. My name is Siobhan Richards. This is my first discussion on programming using Java. And Java is a great language to start with, okay? Java is platform agnostic, right? So it performs well on many different systems due to the Java virtual machine. It's a great starter language. Many applications work with Java. So let's dive in, right? Okay, so you've never written a line of Java code before, right? So let's discuss the history of computers, just to get understanding of how we've reached to this point where we're programming software and so on. Okay. All right, so let's discuss the von Neumann architecture, computer architecture. Well, you have this thing called the von Neumann machine. It takes in some input. This could be from files, clicking a button, camera, any sort of data, right? Then you take that input, you move it to the central processing unit, which is made of the control unit as well as the arithmetic logic unit. And the important part here is memory, okay? So this memory layer here is where you could store different source code, right? So your Java code could go into memory, as well as the data, it could go into memory. And then later, if the central processing unit needs that source code or the data, it could retrieve it, do the processing, and provide some output matching your business logic. Okay, so this is the hardware side, right? So we have these CPU sockets, AGP slots, and so on. So this is like your motherboard, okay? So that's the von Neumann machine. And again, the von Neumann machine is made with these four components. So you have your input, right? So it's from users, sensors, whatever data that you could gather to insert into the computer. You also have the arithmetic logic unit, carries out mathematical tasks, right? So these are like bit shifting, selection of bits and so on. Control unit is like a orchestrator, right? So it orchestrates the different processes, right? So if you've ever done Control Alt Delete, you'll see these different processes being orchestrated, right? So it provides priority here, some there, and so on. So that's a control unit. Memory, again, the important part for the reprogrammable computer. You could store your software, your source code, source files, as well as data in binary, right? So ones and zeros. So what's the benefit of the von Neumann machine? Before the von Neumann machine, you had specific purpose computers, right? So computers were coupled, right? So the hardware and the software came together. The von Neumann machine allow you to decouple the hardware from the software. What did that do? So today you have your laptop, desktop, smartphones. That decoupling allow us to create many different application software on the software side using the same underlying hardware. Otherwise, we'll have many different computers for one specific purpose. So for example, you have a browser application, you have image processing application, you have file text editor application. These are all software, right? And it's running on the computer you have, so it's one hardware, okay? So that's a reprogrammable computer, right? Otherwise, we'll have to have a computer for browsing, a computer for text editing, so several different hardware to match the software. So that's a specific, versus today we have our general purpose computers. And I hope that makes some sense here. Okay, so the von Neumann machine allows us to have reprogrammable computer, right? So same underlying hardware, many different software. And why is that good? Making hardware is very time consuming, right? Versus making software, which is a bunch of files. Okay. So again, what is software for a computer, right? So software is written using some language, right? So some programming language, whether it's C++, Java. In our case, we're using Java, Python, Rust, Go, whatever language it is, right? It's just a tool. So this language is broken down into bytecode, then machine code, right? And then it's passed to the underlying hardware as digital signals, right? So in this case, as a Java software engineer, you'll create, let's say, some file hello.java. You'll print, let's say you want to print hello world, system.out.println, print line hello world inside your hello.java. You'll call the Java compiler, right? And it breaks down the source code to bytecode. Then the bytecode eventually turns machine code, which feeds the underlying hardware. And if we should dig a little deeper, right, the underlying hardware is from electrical engineering theories, right? So combinational and sequential circuits, right? So these are logic gates. So combinational circuit doesn't have any clock, right? Sequential needs a clock, right? So you need some timer there. So the series of these coupled together is what creates our CPU, right, or central processing unit, right? So combinational, sequential logic, they read in the data and manipulate the bits to provide the intended output for the user. Okay, so what is programming? Programming is writing code in a given language to achieve a desired result. So whatever business result you need, you write the code to match your user story or whatever intended value the software brings to the user. Okay, so you manipulate the computer's behavior via a programming language or application. Okay, so what determines well-written code, right? So just remember, Java is camel case, lower camel case. It should be readable, understandable. So variable names, function names should be meaningful. Okay. Consistent formatting, modular, organized, right? Do not repeat yourself, minimal complexity. Should be well tested, right? So unit testing or end-to-end testing, a lot of different testing, right? So you want to make sure one module works before moving on, right, to the next user story. The other thing is you should have some version control. So git perforce, okay? So this is used to track your changes on the source code, right? Maybe you did a change, did some update. If you made a mistake, you could revert. You could go back to older commits and stuff. So it is great to have some version control in your code. Okay. So what is the software development lifecycle? So if you have ever taken a business class, or maybe not, the business side, you have these life cycle methods. So these are stages, right? So like, for example, let's say a woman have a baby. It's a maternal life cycle, right? A maternal cycle, right? So cycle means, a flow. So in business, the life cycle methods are used for the stages in a product, right? Stages in a business. So we've taken those ideas and applied directly to the software, right? So now we view the software as a product. So the software goes through planning, defining, design, testing, and deploy, right? So that's agile. So agile is a feedback loop, right? So maybe you don't have all your user requirements yet, right? You don't have all your designs yet, but you could put something out into the market, see how users interact with it, and make some improvement, and then redeploy. So you keep doing this process over and over again. Okay, that's agile. So usually you hear agile software developer. Waterfall, on the other hand, is linear process. So you get all your requirements, you get all your designs, UML diagrams, CRCs, sequence diagrams. You do your implementation, you start creating your classes, and then you maintain the software after you deploy it. Okay. There are cases where waterfall is better than agile, safety critical cases, okay? So that's agile versus waterfall software development lifecycle. And you have other lifecycle methods, but these two are the clashing cases here. The next thing you need to know before you write your first line of code is developmental tools, right? So you need tools to write your software fast, right? The first tool you need is an integrated development environment. This is used for source code editing. You could use Word, right? You could use PowerPoint, right? But they're not optimized for writing code. So these IDEs are best used for code, right? They're designed to help you to write code better, right? So they have code completion tools such as GitHub Copilot. You have, for example, Prettier, all these different plugins inside your IDE to help you make your code clean, and also help you manage your code better as you code. So it makes your coding faster. Okay, rich ecosystem for different languages. Okay. The next thing you need to know as a software developer or coder is a scripting language. Why do we need scripting language? Well, your computer, remember from the von Neumann machine, you have your hardware and you have your software. The software side is made of application software as well as system software. The system software sits right on top of the hardware, right? So right on top of the von Neumann machine, you have this operating system which contains the kernel. So the kernel have total control over all these different components in your computer. So with your scripting language, you'll get direct access to the kernel, and you use that through a shell, right, or a command line, right? So via the shell, you could access these different system level commands, such as create a directory, kill a process, start a process, and so on. So it's more control over memory, monitoring the system, and so on. So knowing some scripting language, it'll help you later, because when you create your application, there may be times where you need to do system level commands, right? So maybe you need to access some argument from the command line or send some argument to the command line to better manage your system, maybe a server or something, okay? You might not know what I'm saying here, but it's good to look up scripting language. The Git Bash, Git has a born again shell, and you could use that shell. It helps with uploading files to the Git repository, track your changes as well. So it's a good bash to have, okay? And it's nicely integrated into VS Code, which is my editor IDE of choice, okay? So VS Code is the editor of choice. So let's get started with Java. A little more discussion here, and then the next video we'll go into data types in Java. So just some more discussion here. So as a programmer, you'll have syntax errors as well as semantic errors. So when you write code, you'll have errors, okay? Be okay with errors, be at peace with your compiler, okay? So syntax errors are structural rules, right? So grammar, punctuation, right? So can this token follow this token? Similarly, in English, you'd have a subject-verb agreement, right? So in the programming language, you have these tokens, and can this token follow this token in the parse tree? It's like okay. So also you have semantic errors. Are you understanding the business logic? So semantic errors are typically the one you have to debug and spend time on, right? And do some unit tests on, right? So sometimes you may write code, it's not as efficient as possible. And also semantic, you might not get the business meaning correctly. The code runs and you get some output, but it's the incorrect output, or it's not the most optimized output that you could have. Okay, so semantic errors is where you spend most of your time as a coder or a software developer. All right, so Java has 51 keywords. So first thing on the agenda is reserved keywords. So we have 51 keywords in Java. 2 keywords, const and go to are deprecated. They're no longer used. Right, so what are keywords? Reserved keywords. These are keywords reserved by the language that you can't use as a identifier or a variable or function name. You can't use these as function names, okay, or variable names, right? So these are some examples here. You have class, native, new, right? So this is like you're creating a new object. Throws, try, void, volatile, and so on. So these are all reserved keywords in Java. You don't have to know them by heart. One hint is that when you type a reserved keyword in your IDE, you'll see it turn maybe blue, right? So it'll turn blue to show you that it's a reserved word, okay? So reserved keywords are words that have special meaning in the programming language. cannot be used as identifiers, variable names, function names, class names, and labels. Okay, so they're set aside by the programming language. The other thing that you need to know before writing a line of Java code is your scope. How do you do scoping? So you have global scope versus local scope. Do I want this variable or function to be seen by these other functions, or to be seen by all the functions in my code, or do I want it to remain locally to the function? And to show scope, you use your curly braces. So these curly braces here scopes this public static void function, right? So on system.print is a part of this main function that's in the scope of the main function. And Java needs a semicolon to end a line of code, okay? Similar to C++. Okay, so what are data types in Java? In Java, first and foremost, Java is statically typed. You have to tell the compiler the amount of memory you need, right? So if it's an integer, you have to say int. If it's a character, you have to say char. If it's a string, you have to tell it you need a string of. So these int, char strings are primitive data types, and they're tied to some memory allocation in the code, right? So that's why it's statically typed here. So Java have 8 primitive types, and it has 5 reference types, okay? So these built-in types, they handle and store data and process it to give some desired output. So just remember from the von Neumann machine, it's kind of the same. Remember the underlying hardware of the von Neumann machine is that input, CPU processing thing, memory, output. Kind of the same thing in coding, right? So you have some input, right, which is of some data type. You do some processing and then you get some output, right? So you're really rewriting this von Neumann machine over and over. These are high-level abstraction of the underlying von Neumann machine that creates the computer. All right. So what are the 8 data types in Java? We have the byte type, short type, int type, long type, float type, double type, char type, boolean type. So these are all the 8 primitive types in Java. And in our next video, we'll go through declaring and initializing all these data types in Java. So here you can see here with the byte type, it's a 8-bit signed 2's complement integer. So it's a signed data type. So the range is from -2 to the 7 to 2 to the 7 minus 1, right? So -128 to 127, it's 8 bits, okay? And we could see here, right? So that's byte type, okay? So we'll go through declaring and initializing the byte type and all the other primitive types in Java in our hands-on Java video. Okay, thank you for listening. I hope I'm making some impact here. All right, thank you again.